The galvanometer shown at the top is a device for measuring current. I'll use this as a reference for how to detect the direction of current in the situation below. Here we see that current is flowing to the right through the galvanometer. And when that happens, the needle on it is deflected to the right. Now we want to see which way, if any, will the galvanometer needle be deflected below. The galvanometer here is connected to a loop, and we have a south magnetic pole that's going to be moved toward that loop. Will there be an induced current in the wire? To analyze this situation, I'll draw the loop. I drew 2 copies of the loop because we want to analyze the before situation and the after, because there's a motion of the magnet involved. The south pole is going to be coming closer to the loop. And we want to see what kind of magnetic flux is existing through the loop before, and then how does that magnetic flux change as time goes on. So we had seen in the past that magnetic field lines will point toward a south. And in the before case, there could be a small number of magnetic field lines penetrating through that loop. But when we analyze what happens as time goes on, the magnetic field is now going to be stronger through the loop because the magnet has gotten closer. So we see that the magnetic flux due to the permanent magnet is flowing to the left through the loop or coil. And we also see that as the magnet gets closer, that flux is going to be increasing. Those are 2 important things that we need to take note of. Which direction is the field pointing, and is that magnetic flux increasing or decreasing? Because according to Lenz's law, there will be a current induced in this coil in order to stop the change in flux. There will be an induced magnetic flux. And it will oppose the increase. So we're going to need an induced field that points this way into our loop. It's called B induced. And now we just want to grab a hold of the wire itself using the right hand rule and try to figure out in which direction must current flow in order to create a field that goes into the coil from the left-hand side. Okay, so you grab a hold of the wire with the right hand. And when you do this, the thumb points down. So the current direction is going to be clockwise. This way. Now we said above that when current flowed to the right through the galvanometer, the needle would be deflected to the right. But here we see that current is flowing to the left through it, so we expect that while our magnet is in motion, the galvanometer needle will be deflected to the left.